the next page here then is about gases. Just a general look at gases. Like I said, chapter 11, we're going to look at very specifically at gases. So the kinetic theory model has helped us develop this idea of an ideal gas, which we use as a model to compare with real gases. Okay, so the ideal gas is hypothetical, which means it doesn't actually exist. But this ideal gases fits all those assumptions of kinetic molecular theory. So that we can use this to determine properties and actions of real gases. Okay, so a real gas, how is it different from an ideal gas? Well, or what makes something a real gas? Well, for one, it's real. These are actual gases in reality here on Earth. And real gases do not totally behave according to the assumptions of the kinetic molecular theory. But the theory does explain properties of gases. If we use the theory as a model, we use the ideal gas as a model, that helps us explain some actual properties of real gases. So what are some of these properties? Well, number one, expansion. Gases expand. And that means they have no definite shape or volume. I think I'm going to throw in here a little video I made for physics, and it'll sound like I'm talking to physics, but it demonstrates how gases are compressible, okay? I'll throw that in here after this. Okay, so what that means is because gases have no definite shape and no definite volume, and what do we mean by definite shape? Well, for instance, the air in my tires of my car, what shape is that air? Well, it's in the shape of a tire, you know, a donut shape, so to speak, okay? But if I brought that air from my tire into the classroom here, and I let all that air out into the classroom, what's going to be the shape of that air then? Well, it's going to be the shape of a somewhat cube, right? It's going to look like a rectangular prism. That's going to be its shape. So no definite shape and no definite volume. And what this simply means is that gases are compressible. And again, that we've done that in science class, but we'll do it again. I'll do the little demo of showing you how gases are compressible. Therefore, because they have no definite shape and no definite volume, a gas will fill any container completely. Any container in which they are enclosed, I should have fixed that, in which they are enclosed will take the container shape. They completely fill a container. Now, what is this first property of gases based on? Well, it's based on assumptions 3 and 4 of kinetic molecular theory. We can look at the assumptions 3 and 4 and realize that this will lead to this idea of no definite shape and gases filling their container. Let's go back to assumptions 3 and 4 really fast. Okay, so down here, assumption number 3, gas particles are in constant motion and therefore they possess kinetic energy. Do you see how that leads to the idea that gases will fill their container? Because they're always moving, always bouncing off of each other, they're going to get farther and farther apart, okay? And assumption number 4, there are no forces of attractions between the gas particles, so they immediately bounce apart after the collision. You could also throw assumption number 2 in here, has to do with those collisions. And what those collisions do, because these things are moving, is it just causes the molecules to get farther and farther apart. All right. Second property of a gas, of a real gas, I'm going to look at, is fluidity. A gas is a fluid. Any gas is a fluid. A fluid just means it's something that has the ability to flow. So if it flows, it's a fluid, and gases do flow. This is because gas particles glide easily past each other. And again, why do they glide easily past each other? Well, let's look at assumption number 4 here again. Because there are no forces of attraction between them. Now, it's a real gas, there are some, but those forces of attraction are very small. And because of that, they easily flow past each other. They don't stick to each other very well. So that's from assumption number 4. Okay? So, expansion and fluidity are a couple of properties of gases. I think I'm going to stop the video now, take a little break, come back.